Now we can start look at applying these problem-solving strategies to some application problems. In example 11, Francis wants to buy coffee for their coworkers. If everyone's favorite drink costs $4.18 with tax, what is the maximum number of drinks they can buy if they have $20 to spend? So we know that drinks cost $4.18, and the question is, how many can they buy? So 418 times X would be the number purchased, and that has to be less than or equal to the $20 that they have to spend. To solve, we'll multiply both sides by that reciprocal, or we can just think of it as dividing both sides by 4.18. To get X is less than or equal to 4.7847, however far we carry that out and round. Now we have an inferential step that we need to take care of. We can't buy a portion of a drink, so we either have to buy 4 or 5. Our natural rounding rules would tell us to round this number up to 5, but if we did that, then we would have a value that doesn't fit this inequality statement. 5 is not less than or equal to 4.78. So what we actually have to do is infer that we need to round this down and say that they can buy at most 4 drinks. Because once they purchased a 5th drink, they would go over the $20 that they have to spend. In example 12, Sarah charges their client $17.50 per project. How many projects must they complete if their goal is to earn at least $1,200? So we charge $17.50, 17.5, times X per project, and we want that to be greater than or equal to $1,200, so that we're earning at least $1,200. Dividing both sides by 17.5 would give us X is greater than or equal to 0.5714. And now again, we need to think about whether our answer should be 68 or 69. Should we round that number up or down? If we rounded it down to 68, that would not be a solution to this inequality statement. So in this case, we need to round up to say that she needs to complete at least 69 projects in order to hit that goal of earning $1,200. In example 13, Cleveland wants to throw a birthday party for their son. An indoor climbing gym charges a $950 rental fee plus $13.50 per child attending. How many children can attend if they want the maximum cost to be $1,200? In this case, we have a fixed rate, which is that $950. We pay that regardless of how many people attend, plus a variable rate of 13.5x, since we pay $13.50 per child attending. We want the maximum cost to be $1,200, so we want this to be less than or equal to $1,200. We'll first subtract $950 from both sides to get 13.5x is less than or equal to 250. Then we'll divide both sides or multiply both sides by 1 over 13.5. Which will give us X is less than or equal to 18.5185. We can't invite a fraction of a kid, so in this case, we would say that we could have at most 18 kids invited to this party, because once we hit the 19th kid, that would no longer be a solution to that inequality statement that we found. In our last example, Connor charges their clients $75.50 per project. Their monthly business expenses are $2,300. How many projects must they complete to earn a monthly profit of at least $2,100. This is different from example 13 because now we have this information about their monthly business expenses that they're keeping in mind. So we have $75.50 per project, so 75.5 times X. We're going to factor in those monthly business expenses as minus 2,300. So we want the amount they earn from their projects minus their expenses to be at least $2,100. To solve, we'll add 2,300 to both sides, giving us 75.5x is greater than or equal to 4,400. Then multiplying by that reciprocal or dividing both sides, we'll get x is greater than or equal to 58.2781. In this case, that tells us that they need to complete at least 59 projects a month to bring in enough money to cover those monthly expenses plus earn that minimum of $2,100 a month.